Okay, so again, section 2, we're going to start with these 3 topics. We're talking about least squares regression. We're going to talk about interpreting the slope and y-intercept of the equation line. That's similar to what you guys have already done. Okay? Use least squares regression line to predict y for a given x. You've done that before as well. We talked about dangers of extrapolation yesterday, but I don't think I recorded it, so we're going to put it on video. And then we're going to calculate and interpret residuals. Okay, so I need, you guys okay if I move this up? No, okay, I'll wait for a second. Okay, so there's an experiment done where cans were shaken randomly, okay? And then the tops, they were placed on a countertop, and then the tops were either tapped for 0 seconds, 4 seconds, 8 seconds, or 12 seconds. So here, let me pause it real quick. What they did is they shook up, and then they tapped the tops for 0, 4, 8, or 12 seconds. Then they were open. Then the remaining soda was measured in milliliters. So this column right here represents the 0 seconds. So what I'm saying here, the x value, the ordered pair would be like 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, comma, 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 and then you have to do all your parentheses. Thank you. I was thinking the same thing. So I was lazy and went with, here's the x values, and then here's the y values, okay? So I've been kind of showing everybody. I just typed in my zeros, and then I moved my cursor over, and it would take me to the top of my list, and I could type in the rest of my data set, okay? So I want you to enter the data set. I want you to find and complete a scatter plot. So that's your first assignment. Well, not your first assignment, but and then you're going to state the association that you see, okay? And then we're going to write our least squares regression line, okay? And so hopefully that majority of it will be a review for you. And if not, we'll get you so that you can take your notes and everything will be just fine, okay? Okay, so if you've entered your data incorrectly, you should get your A is equal to 2.635, your B is equal to 248 and 64 milliliters. R squared, we're going to talk about on Friday, I think. And then R, we've kind of talked about last couple of days. We'll bring that up here in just a second, okay? So the first part says, find and complete a scatter plot, which we did. So it looks something like that. I asked you to state your association. So what's our association do we see? Yep. It's a okay. How can we say that it's strong? Okay, so we're going to go back and use our R value, which is right here. It's close to 1. It fits into our parameters we talked about. So this is a strong positive association. Okay, so then my linear regression line or linear or least squares regression, we're going to say y hat is equal to 2.635 plus 248.64. Okay, now if you got a little bit off of there, you know, probably could have been my handwriting or something like that, okay? So the next part, so we've done 1, we've found and completed a scatter plot. We stated the association, right? We wrote the least squares regression line. And so the part that should be a little bit new for us, but not really because you guys did it all the time in Algebra 1, okay? So interpret the slope. Well, I know the slope to be what again, guys? Perfect. Now, you guys know that it's the change of y over the change of x, right? So if we look at the y, what is the y in our data set? Milliliters of left, right? What's my change of x? Seconds. The soda can were tapped, right? All right. So if I interpret the slope, it's going to be there is 2, and I'm going to rate this up a little bit for the guys in the back, 2.635 milliliters of soda left for every, and what's our denominator? What's the number? If it's 2.635, what's that over? It's going to be over 1, right? So there's 2.635 milliliters of soda left for every second the soda can was tapped. So when it says interpret the slope, all you're doing is just going to state what the units are for your y, state your units that are in your x. You don't have to put in some English paper fluff that's going to be like, oh, because of the fingernails or because of the thickness of the, you're just stating what's happening. Okay? Okay. Questions on interpreting the slope or anything along those lines? Okay. Now, the problem is, we talked about this yesterday. We'll come back to this here in a second. Is at 0 seconds, which kind of fits into our data set, right? So our data set says at 0 seconds, there's how much soda left in the can. Okay, so at 0 seconds, soda left in the can is 248 and 64 seconds, right? Now, this actually fits into our data. So are we doing an extrapolation? No, what's an extrapolation again? So when it's outside the data. So if I was to do an extrapolation at 14 seconds, because it's outside of our data range, that's an extrapolation, okay? It would be a pretty good predictor though, we would think, okay? If I did it for 30 seconds, that would be a very strong extrapolation that probably wouldn't work, okay? What about, what's it called when it's inside the data set? Interpolation, okay. So what we're gonna do next is we're actually gonna do a prediction using our equation, okay? So we've got y hat, oh, let's see here. I'm gonna do it the correct way. I keep forgetting this. Soda left, so I'm making a prediction. So when I put that little hat on top of it, that's my prediction. That's letting the reader know I'm predicting something, okay? We're gonna do 2.635 x plus 248.64. Okay, so the first thing we're going to do is we're going to first just do an extrapolation at 5 seconds, okay? So we're just going to predict that real quick. So all I'm going to do is plug and chug. Okay, so our two predictions have been at 5 seconds was at 261.815. At 4 seconds, we're at 259.18. Now, if we go back, this is what we observed, right? That's what we observed, okay? So our residual is equal to observed minus predicted. Okay? So observed is what we actually did. Predicted is what we use when we use our least squares regression line. Okay? So again, we're talking about what's left over. This is our residual. And what we have for that is our observed minus predicted. Observed comes from our data set. Predicted comes from our column or from our equation up here. And so our residual is that we're 82 milliliters or 0.82 milliliters above what we predicted. Okay. And what's going to happen is we're going to have stuff that's going to be above it. We're going to have stuff that's going to be below it. Okay. And so we're actually going to see kind of that plus and minus type of a thing. Okay. So all we're going to report is that at the observed value of 4 seconds and 260 milliliters of soda left, there was a 0.82 milliliters residual. So when it's asked to report and interpret, that's all we got to do. You're just reporting and interpreting the numbers, and all that when it says interpreting numbers are is you're putting the units down. Milliliters, seconds, you're done. No fluff. No fluff. Okay? So the residual, what is it? It's the difference between an observed value of the response variable and the variable predicted by the regression line. So it's the formula up here, and then this is using the symbols. The y is the observed, and then the y hat is using the formula. So we know that that is, whenever we talk about a y hat, that's our predicted value. Okay? Now, we're going to go into more detail of what exactly that residual does for us. Okay? But kind of wanted to promise you guys that same thing I did earlier. Those are the 3 topics that we've covered. Okay? We talked about interpreting the slope and y-intercept of the least squares regression line. We've done least squares regression line to predict y for a given x. We've talked about the dangers of extrapolation, and we've calculated and interpreted results. Okay, so all we're doing right now is just reporting what we see. Okay, we're not making any strong associations or anything like that with it. We're just showing that this is what's happening. Okay. Okay, so your homework for this section, number 1, is going to be on page 193, numbers 36, 38, 40, 42, and 46. And I double checked the page so I didn't screw it up this time. Yay me. Okay. And then if you guys have any emails, if you're watching it at home, student P, then you can email me. We'll talk about it. Tomorrow is my office hours. We can talk about it then. They still not letting you guys, well, they're not supposed to let you come in. I think there's teachers breaking the rules all the time. But anyway, so, but anyway, that's where we're at, and then what we can do to help you out. So you guys got lots of time to work on your homework.